So this section is covering probability and the fundamentals thereof. So what we're going to hope to be able to do by the end of this video is to be able to figure out how we can compute theoretical probability and to compute empirical probability. So first, let's discuss what we mean when we're talking about probability. So probabilities are values that range from 0 to 1. Now, oftentimes those are written as percentages that you're more likely to have seen. So for example, it goes from 0% to 100%, but the decimal range of that is from 0 to 1. Okay. So if I look at my breakdown here, going from 0 all the way over to 1, we'll note that if something has a probability of 1, then it is said to be certain to occur. If a probability has a probability of 0, then it is said to be impossible to occur. So such things will not happen. Okay. Then if we have our 50-50 probability, this is a 1/2 chance, so this is where it is equally likely that it will happen and it won't. And if you're between 0 and 50-50, then that means you are unlikely. If you are from 50-50 to 1, then that means that you are likely to occur. Okay? So that's kind of just our breakdown for what probability is and what probability is going to be looking like in terms of the numbers or the type of numbers that we can expect here. Okay? Now, the first type of probability we're going to mention is called theoretical probability. So when I'm talking about theoretical probability, I mean it is a probability that is not based on observation, but rather the probability that events happen in a theoretical case. Okay? So when we're dealing with theoretical probability, there's some things we need to note. So we're going to be talking about experiments. So an experiment here is just an event where the outcome is unknown or is uncertain. Okay. Then we talk about our sample space. The sample space of any given probability is where we're looking at all possible outcomes. So this is the set of all possible outcomes. Okay. And this is usually given capital S to represent our sample space. Okay. And then we also have events. So an event is just a subset of our sample space. It's just one of the things that can occur in our sample space. Okay. Now, one thing to note is that the probability of something in our sample space occurring is 1. Because if we think about it, well, what's the probability that something happens out of all possible options? Well, the answer is 1. We're guaranteed that something is going to happen within our range of possibilities whenever we look at theoretical probability. Okay. Now, the equation that we're going to use throughout, and this is one of the key formulas, is that the probability of some event E is found to be the number of ways E can occur over our total number of possibilities. Okay. Now, we can actually represent that symbolically by making use of cardinality. We see it's the cardinality of E, so the number of ways that E occurs, over the cardinality of my sample space. So it's just how many ways can it occur over how many total possibilities there are. Okay. So let's go ahead and just calculate some probabilities here. So let's suppose that I am rolling a die, okay? A regular old 6-sided die. I want to know what is the probability that I roll a 3. Okay. Well, how many ways are there on a 6-sided die for me to roll 3? There's 1. It ends up a 3. Out of the sample space. So when I roll a die, what are all the possible options? Well, it's 1, 2, 3, 4, 5, and 6. So that means that the cardinality of my sample space is 6 here. So the probability that I roll a 3 is 1/6. Okay. What's the probability that I roll an even number? Well, how many even numbers are there on a 6-sided die? There's 2, 4, and 6. That means there's 3. Out of all of our possible outcomes, how many possible outcomes are there? 6 possible outcomes. Okay. Hopefully that makes sense to everybody there. What's the probability I roll greater than 4? Well, how many numbers are there greater than 4 on a 6-sided die? There's 5 and 6. So the probability is 2 out of 6, which I can simplify to 1/3. I can also simplify this to 1/2. Okay. What is the probability then that I roll greater than 6? Well, how many ways can I roll greater than 6 if I have a 6-sided die that goes 1 to 6? Well, there's 0 ways that it can occur out of 6, so that gives us a probability of 0. Which makes sense, because it's impossible for us to roll a number that is greater than 6 on a 6-sided die. Okay. What about the probability that we roll a number greater than 0? In that case, 6 of them are possible out of a total of 6, so we see that's 1. So again, that makes sense because all of our possibilities are there over all the possibilities, so that means that that is certain to occur. Okay. Hopefully that makes sense to everybody there. Let's do another one. Let's suppose that we are taking a look at a deck of playing cards, okay, our standard 52 card deck. And let's say that somebody shuffles up the deck, and then they pass you a card. Okay. What is the probability that you got a 7? Well, how many 7s are there in a deck? Well, 1 for each suit, and there are 4 suits out of 52. We note that 4 and 52, this shares a factor of 4, so this is 4 times 13. Cancel the 4s, and I get 1/13. So that's my probability there. Okay. What about this next one? Let's suppose I'm looking at the probability that I got a heart. Well, how many hearts are there in the deck? Well, there are 13 of them out of 52. Another way we can think of that is 1/4. Okay. Hopefully this makes sense to everybody here. We are just looking at these nice simple probabilities when we have one case or one example that we're looking at. Then the next thing that I want to mention in this section, and the last thing I want to mention, is what's called experimental or empirical probability. Okay? When we're dealing with experimental or empirical probability, what that is, so this is empirical probability, this is not basing it off of necessarily a mathematical collection. This is not something that we deduce from principles. Rather, this is just what we find from observation. So the probability of some event E in that is the number of times E occurred. Note, this is occurred, so this is past tense. So these are based on observations. Over the total number of trials. Okay. So let's suppose I flip a coin, and let's say I flipped it 500 times. And let's say 200 times it was heads. I want you to tell me what is the empirical probability that I flipped a heads. Okay. Well, to find the empirical probability, what I'm going to do is I'm going to take the probability of 200, well, or rather the probability of heads here. How many times did I get heads? 200. Out of 500 flips, that tells me that it is 0.4. Okay. Now, we obviously know that it should be 0.5, which is where a principle which is known as the law of large numbers gets in. What the law of large numbers says is the experimental or the empirical probability approaches the theoretical probability as the number of trials increases. That is to say, basically, eventually, as you get larger and larger and larger, you will get closer to what the actual probability is. In fact, there are several different types of probability and modeling that will use the law of large numbers in order to find shortcuts for calculating what the empirical or what the theoretical probability is. Okay, so you'll often see that programs will, instead of actually just trying to calculate it, because it might be very difficult to calculate a given probability, they might just have a program to simulate and find out how many times it was after, say, 10 million trials. And that's generally going to be a pretty good estimate because it will eventually approach what the actual probability is. Okay. Hopefully that makes sense to everybody here. Now that's actually all I have for this section. Let me know if you have any questions or you want to see any more examples. Otherwise, I will see you in the next video.